Hello. Today we're going to talk about how to use a laser level. Laser levels are very important because they can show you the measurement, the height of previous land, or it can also get you the proper measurements for calculations to do to find a plot. So first thing you'll need, everything you'll need to do this is a laser level, the tripod, a sensor or laser detector, and a rod. And of course something to write your information down on.
Before you start, a little bit of safety, proper clothing, safety glasses, and steel-toed boots.
You want to set your tripod up so that it's level. It can be out of level because the laser level will level itself to a certain point, but you want to have this as level as possible. There is a nut on the bottom of the laser leveler that will hook up to your tripod. Now that it's hooked to your tripod, you're able to turn it on. At this point, it self-levels itself if you're close enough to level with your tripod. Now you can see the laser turning around, and now you're able to set your benchmark. In this demonstration, we're going to call this our benchmark. A benchmark is something that is a measurement that will not move, so that will not change. The benchmark in this case will be 100 meters. After a benchmark is set, we're now able to take a backsite measurement. So in order to do this, you're going to want to connect your laser sensor or detector to the rod. And now our laser is set up over there. So we will be setting this above our benchmark to find our height of instrument. The laser detector is on, and you can change each setting by just clicking the power button, and it'll let you either have sound or not have sound. So once you start setting your benchmark, you can start by putting it above your benchmark in your meter stick, and you're now able to move it up and down to find now that it starts beeping, it tells me that I need to go lower. So I will set this up on this lower area of the rod. As you can see, there's an arrow showing that I need to go lower. It's beeping slower. I need to go up. The flat line means I am right on my measurement. It is important to make sure that your rod stays straight up and down. Now that I have my measurement, I can read what the measurement is for my backsite. So in order to read this, you can see it goes from 0, 1, 2, 3, 4, 5, 6. So our measurement would be 0.6, and then each line here is a centimeter, and then inside those we can find our millimeters. So in this case, I know that it's above here in 6, so I can tell that it's going to be 1, 2, 3, 4, 5, 6, 7, 8. So it's just above 8. So I'm able to say it is 8.681. Now that we found our measurement, we're able to calculate our height of instrument.
Your height of instrument is BM plus BS. BM is your benchmark, and your benchmark will never move. Your back sight will only move if your height of instrument moves. So now we're going to start looking for measurements around the land and see what an IFS is.
Each time you take an IFS, you will want to make sure that you label that area properly. In this demonstration, we won't be labeling our areas, but it's recommended to either use a stake, a painted dot, or GPS coordinations. The GPS coordinates will be the best to use for this if you're in a depending on your work site. But it'll be easiest to find all of your IFSs this way.
Leveling out the heads and using the nozzles and that type of thing. Once you have your data, that's right.
So now you can calculate your IFS. Your IFS is places on the ground that you're looking for elevations.
Now that you have different IFS measurements, you're able to calculate your elevations for each area that you tested. In order to get that calculation, your elevation equals your height of instrument, which we took over there, as well as, and so your height of instrument, subtract your IFS, and it'll give you your elevation for every spot that you measured. There is another way to find. So in order to find, you can find your IFS by using another equation. So your IFS, to find that, it equals your height of instrument subtracted by your elevation. This is used for if you're given a certain elevation that they want a plot to be set at, you're able to tell that. So with that calculation, which we'll show you in a little bit, it will actually tell you where you want your laser to be on your rod. And that'll give you your exact plot height working backward. Okay, so now that we have our data, which I've posted here in the blue, we are now able to put this data into this Google Sheet that will calculate all of our equations to find our elevations as well as our IFS if we're working backwards. So what I did here was I started with the base measurement on the right-hand side. It is 100, is what we've set the base measurement at. When we measured our base site is 0.681. So when you add both of those together, we get our height of instrument, which is 100.681. Now, because this is Google Sheets, I was able to make the formula so that our height of instrument, because it will stay constant as long as we don't move our laser level, I have it staying constant for all of our measurements, as well as our back sight will also stay constant in this situation. The next thing we do is we start typing in our IFS. Our first one being 1.16, our second one 1.235, and our third one 1.038. These are all in meters. But because Google Sheets will not be able to calculate numbers with meters behind it, we've had to leave the meters out of it. So with the calculations, we have now determined all of our different elevations for all 3 tries or 3 tests that we did using this equation in the notes section right beside it. So if we were wanting to work backwards and our boss was to give us a elevation that he wants a retaining wall set at, we will start off with our base measurement being 100. Our base site is again 0.681. Our height of instrument is 100.681, all in meters. And now we have our elevation being 99.7. This now calculates our IFS to being 0.981. This means that if you put your laser sensor at 0.981, then once it shows the laser at 0.981, that means your elevation will be 99.7. And that also uses the equation right below.
In conclusion, we hope this video helps you with laser leveling, and we hope it helps you finding elevations and measurements.